Good evening, dear students. Yes, so we are discussing the MCQs on the chapter solutions, right? Our first chapter from chemistry solutions. So we have seen almost, I think, 25 question. Okay, few more question, and then complete with the solution chapter. Then next class onwards, we are going to start with the next chapter. Okay. Okay, so let us start. So I guess I have completed some 26 or 27 questions. Okay. So let us continue from this. So yes, this was the question which I have done. Okay. So let us continue the next one. Yes. So let us go with this. Okay. So are you solving? So I have told you, so if you get any last year papers, okay, or if you have any book, so please solve the questions on on the that is the MCQs on solution chapter, okay, so that you practice. So whatever the formula we have seen, so based on that, please practice the MCQs. So it will help you. Okay, similar type of questions will be there. Okay, so if you find any difficulty, then you can come to me. Okay, fine. Okay, so let us start with this question. So the question is, a non-volatile solute A tetramerizes in water to the extent of 80%, 2.5 grams of A in 100 grams of water lowers the freezing point by 0.3 degree. Okay. The molar mass of A in mole per liter is. So the KF value is given, okay, of water, that is 1.86 Kelvin kg per mole. Yes. So how we are going to solve this particular problem, students? Yes. So I'll read the questions once again. A non-volatile solute A tetramerizes in water to extent of 80%. 2.5 grams of A in 100 grams of water lowers the freezing point by 0.3 degrees Celsius. The molar mass of A in mole per liter is. Okay. So how we are going to solve this? So these are the four options: A 62, B 221, then C 155, and D 354. So this was a question asked in 2019. Okay, this was a question asked in 2019. So how are we going to do this problem? Okay, somebody has answered as association. What about others? How are you going to deal with this particular problem? So what we are going to do here? So we know that, okay. So freezing point is given, okay. So first we will see the I value. So we need to find the I value. Okay. So what we have, delta TF is equals to I into KF into M, right? So here what all things are given, just see. So note down that first, and then you have to start solving this problem. Okay. So what all things are given here? So here, non-volatile solute. So what is happening to non-volatile solute? The non-volatile solute, it is getting it tetramerizes. Okay. So when we are, so what is given here? Alpha is given, right? Alpha is 80%. So what is the extent of association? It is 80%. 80% means 80 by 100. 80 by 100 is nothing but 0.8. Okay. So alpha is 0.8. So remember this. So alpha is what? Alpha is 0.8. Yes. So we are going to use which particular formula? So that is alpha is equals to 1 minus I, okay, n by n minus 1. So this particular formula which we are going to use. So here alpha is what? 0.8, okay. Then 1 minus I, okay. And what is n? N is 4 because it is tetramerizing, okay. Tetramerizing means tetra, so it is the number n is equals to 4. So 4 by 4 minus 1. So now we need to find the I value. So I value we are going to use by this particular formula. So let us use now. So delta TF is given. What is delta TF? The freezing point is lowering by 0.3 degree. So delta TF is equals to I into KF into M, right? So from this, we are going to see the value of I, Vento factor. So I into KF into M. Okay, so delta TF is what? So I'll erase this, I'll write it this side. So alpha is equals to 80%, that is 80 by 100. So alpha is 0.8. Okay, so let us put the value. So this is 0.3 I. Then what is I? So from this, okay, so from this we are going to find the value of I from the above this, okay. So 0.8 into 1 minus 8, 1 minus I, 4 by 4 by 3. So if you solve this, I'm going to get the value of I that comes to 0.4, okay. So solve and see. So we got alpha value, we got I value. Now what is I value here? So 0.4 into KF is 1.86, okay. And molality is what? Molality means what? Weight of the solute, okay, upon the this volume of the solvent in kg, right? So let us, so what kg means? It will be by 100, by okay. So volume will be by so let us see. So molality, okay. So it is in terms of molality. So what I'm going to do? So given weight is 2.5. Given weight is 2.5. Then molar mass. So we need to find out the molar mass of the A, okay, which is the non-volatile solute. We don't know. So that we have to find the molar mass, given weight upon the molar mass of that into 1000 divided by 100. Okay, 1000 divided by 100. So find out the molar mass. Molar mass from this formula. So molar mass is equals to zero point 0.4 into 1.86. So if I transfer this here, this will go down. So 1.86 into 2.5. Okay. So 0, 0, 0, 0 cancel. So it will be 10 into 10 divided by 0.3. Just see what is the molar mass you're going to get. Yes, what is the molar mass you're getting? So first we have found out the value of I by using the formula. Okay, that is alpha 1 minus I n by n minus 1. That is the extent of association. Then what we are going to do by that, after that we are going to use this formula delta TF is equals to I into KF into M. From this, okay. So molality is nothing but given weight upon the volume of that is the volume of solvent in 1 kg. So given weight upon molecular weight divided by 1000. So now, yes, Nanda, Kishore and Sri Varuni has got it as 62. Okay, what will be the molar mass means? It is given as gram per mole. Okay, so option number A. Option number A is the answer. Okay, option number A is the answer. So like this, we are going to find out the, okay, molar mass of the given non-volatile solute. Okay, so this is a way of solving this type of question. Okay, let us go for the next one. Solution A contains acetone. Solution A contains acetone. dissolved in chloroform, and solution B contains acetone dissolved in carbon disulfide. The type of deviation from Raoult's law shown by solutions A and B respectively are. Okay, Sri Varuni has answered it as D. Lubna has also answered it as D. So what is happening here? So what we have done? So we have solution A. Okay, solution A is what? Solution A contains your acetone. Okay, it contains acetone, which is dissolved in chloroform, which is dissolved in what? Chloroform. And solution B, okay, contains what? Acetone, and it is dissolved in carbon disulfide, okay, CS2. So the type of deviation which is shown by both this solution is what type of deviation it is shown. The question is like this, okay? Okay, any more answers? Yes, any more answers? So the four options, I'll read out the four options. A, positive and positive. B, positive and negative. C, negative and D, negative and positive. Yes. Okay. So one more, Kajal Kumari has answered it as D. Fine. So I've got three answers. So let us see. Let us see. So we know that, okay. So acetone, okay. Acetone is what? This is the structure of acetone. So acetone, it has some hydrogen bonding, okay. And CS2, carbon disulfide. Okay, so what you can see here, the solutions of the acetone and chloroform, okay, it will show negative deviation. So it will show what type of deviation? It will show a negative deviation, and the solution of acetone with CS2 will show positive deviation. Okay, it will show positive deviation. So this is the answer. Okay, so non-ideal solutions. Yes, Janvi Kamath has also answered it as D. So acetone, okay, when we have non-ideal solutions, so non-ideal solutions, they show positive deviation. Okay, when they are showing positive deviation, the intermolecular attraction of forces, okay, that of solute and solvent molecules, what will happen? They are weaker. Okay, they are weaker than that of solute-solute or solvent-solvent interactions. So when we are so the non-ideal solutions which are showing positive deviations, what is happening? The interactions, okay, the molecular interactions, they are weaker between the solute solvent, okay, as compared to the solute solute and solvent solvent interactions. Okay, so when we see the acetone, so when we see acetone and your carbon disulfide, okay, they will show some kind of hydrogen bonding. And this kind of hydrogen bonding, it is what is happening because of the presence of the CS2, it is getting lower, or you can say it is getting disrupted. Okay, so because of that, it will okay. So when these acetone and carbon disulfide, when they are mixed, they will show positive deviation. Okay, and when you have a this acetone and chloroform, why they show negative deviations? Because the intermolecular forces of attraction, okay, between the solute and solvent is stronger as compared to that of solute and solvent interaction. Okay, so when you mix the solution of acetone and chloroform, it will show negative deviation from the Raoult's law. Okay, because chloroform, because the chloroform CHCl3, okay, chloroform, what it is doing? It is forming, it is able to form the hydrogen bonding, okay, because the force of the what is that? The interaction between the chloroform and your acetone, okay, it is more, it is stronger. Why? Because it is forming hydrogen bonding. So the intermolecular forces between them are stronger. Okay, so because of this, it will show the negative deviation. Okay, So this is the answer. So option number D. Yes, or whoever have answered it as option number D, it is the correct one. Okay. So this was again the question asked in 2019. Let us go for the next one. Which of the following pair of solution is isotonic? Again, okay, we know what are isotonic solutions. Which of the following pair of solution is isotonic? A 0.001 molar Al2SO3 thrice and 0.01 molar BaCl2. B 0.001 molar CaCl2 and 0.001 molar Al2SO4 thrice. C 0.01 molar BaCl2 and 0.001 molar CaCl2, D 0.01 molar BaCl2 and 0.015 molar NaCl. So this type of questions we have solved many. So I want the answer from you now. Okay, we know what are isotonic solutions. Again, I'll repeat the solutions which are having same osmotic pressure at a given temperature. Okay, so the solutions are said to be isotonic when they are having same osmotic pressure. Okay, so their concentrations are same. So when we see, so what all we have? Al2SO4 thrice. Okay, then we have BaCl2. Then we have calcium chloride and we have NaCl. Okay, so when we find out the value of I, so here the value of I is what? Al plus 3. So 2Al plus 3SO4 SO4 minus 2. Okay. So it is how much? I is equals to 5. Okay. I is equals to 5 here. Then, okay. So it is 0.01. Then barium chloride, Ba plus 2 and 2 Cl minus. So 1 plus 2, I is equals to 3 here. Okay. Then calcium plus 2 and Cl minus, 2 Cl minus. So it is 1 plus 2 again. I is equals to 3. Then NaCl is Na plus and Cl minus. So 1 plus 1 is equals to 2. Okay, so these are the values. Fine. Now, when we are finding, okay, Sri Varuni has got the answer as D. Baby has answered it as C. Okay, so what we have to do now? So let us put the values. Okay, let us put the values here and just see. Okay, Janvi Kamath has also answered it as C. Now here, so first let us see for barium chloride. Okay, 0.01 molar barium chloride. What is I? I is equals to 3. Okay, so pi is equals to, what is the value of pi? CRT. Okay, so here we are taking I. So N is equals to I. So let us take I. So what is the I value? 3 into what is the concentration? Concentration is 0.01 RT. Okay, RT is common, so we'll keep it like this only. So what is the value you are getting? Just see. So I have got it as 3 into 0.01 is 0.03. Okay, 0.03 RT. Okay, this is for 0.01 barium chloride. Now let us see 0.001 molar Al2SO4 thrice. Okay, so for that I is equals to 5. Then pi is equals to ICRT. So I is what? 5 into 0.001 RT. So do it now. 5 into 0.001 is 0.005 RT. Okay. Next is what? This is done. This is done. Then is calcium chloride. So 0.001 molar calcium chloride. So I is equals to again 3. So put the value pi is equals to ICRT. I is 3 into 0.001 RT. So 3 into 0.001 is 0.003 RT. Okay, so this is for your calcium chloride. Again, one is 0.015 molar NaCl. Okay, so I is equals to your 2. Then put the value. So pi is equals to 2 into 0.015 into RT. Do this. So 2 into 0.015 is 0.03 RT. So whose concentration are same, your students? What are isotonic solution? What is the question? Which of the following pairs of solution is isotonic? Means who is having the same concentration. So which is the same concentration? 0.03. Then here is 0.005. This is 0.003 and this is 0.03. So which is this? This is NaCl. Okay. And your barium chloride. So which is the answer now? Can you tell me? Which is the answer now? Yes, I have solved it completely. So did you understood this? Okay. So which is the answer? Now, by seeing the values, at least you can tell me isotonic means what? They should have same osmotic pressure. Osmotic pressure is what? Osmotic pressure means same concentration. Okay, both the solutions should have same concentration. So, which is this? It is option number. Which option? Tell me the option number. Okay, which is the option number? Yes, very good. So, baby Kajal, yes, Janvi has answered. It is option number D. Okay, so barium chloride and NaCl. So these are the pair of solutions which are isotonic with each other. Okay, Lubna has also answered. Very good. So this is clear. Is it clear? So we have solved many problems such. Okay. So is it clear? Okay. So let us go for the next one. Next question. So this was a question asked in 2020. Okay. So let us move for the next one. Solute X dimerizes in water to the extent of 80%. 2.5 grams of X in 100 grams of water increases the boiling point by 0.3 degree. The molar mass of X is. So here this is with respect to boiling point. So there it was. Okay, we have solved a similar problem starting. So there was, it was, the solute was the solute was tetramerizing. Okay, here it is dimerizing. Okay, and we are studying here with respect to boiling point, increase in boiling point. There was a decrease in freezing point, right? Okay, so now use, so given things. So what is the given weight? Okay, given weight is 2.5 grams again. Okay, so given weight of the solute is 2.5 grams. Then what again is given? The solvent weight is given. Okay, solvent weight is 100 grams. Solvent weight is 100 grams. Then what is given? Kb is given. Kb is what? 0.52 Kelvin kg per mole. Okay. Next, what is given? The increase in boiling point, that is represented as delta TB, which is 0.3 degrees Celsius. Okay. First, so let us find the Van 't Hoff factor. So Van 't Hoff factor here. Okay. So we are going to see that is I is equals to 1 plus alpha 1 by n minus 1. Okay. Yes. So just see now. Put the values 1 plus alpha again. Alpha is what? 80%. That is 0.8. Okay. So there are four options: A52, B65, C26, and D13. So put the values. So alpha is 0.8. Okay. Then 1 by 2 minus 1. Okay. So find the value of I now. What is the value of I after solving this? So you will get 1. So, okay. Do stepwise. So how much you are going to get? So I'm going to get 1 minus 0.4. Okay, that is 0.6. Are you getting same? Yes, I is equals to 0.6. Okay. Now delta TB. Delta TB is equals to I into KB into M. Okay, what is the value of I? I we have found out 0.6. Then into KB is phi 2. What is the okay? So given mass upon MB into 1000 divided by 100. Okay. See what you are getting? Okay. So after solving this, so take this MB this side. Okay. That is the molecular, we are going to find the molar mass. Okay. Molecular mass of the X, that is your solute. So 0.6 into 0.52 into 2.5. MB goes there. So into, so this is into 10. What is delta TB? Delta TB is 0.3. Okay. So divided by 0.3. So after solving this, how much I am getting? I should get as 26 gram per mole. Are you getting the same? Yes. Okay. Kajal, Kumari, Baby, Shrivaruni have got it as 26. Janvi has got it as 26. Very. Okay. Yes. Fine. So 26 is the answer. So the molar mass we have found out to be how much? 26. Okay. Fine. I hope. Okay. So find such similar question. So you can see. Okay. So only the difference how the question is asked. So once if you understand the type of questions, you can solve any such questions. Okay. Let us go for the next one. Henry's law constant for the solubility of N2 gas in water at 298 Kelvin is 1 into 10 raised to 5 atm. The mole fraction of N2 in air is uh, 0.8. The number of moles of N2 from air dissolved in 10 moles of water at 298 Kelvin and 5 atm pressure is. Yes. So partial pressure is given, partial pressure of N2 in air. Okay. So let us find out. So this is based on the Henry's law. So this is a question based on Henry's law. So partial pressure of N2 in air. Okay, so you have to find the number of moles of N2 from air dissolved in 10 moles of water. Okay, so at 298 Kelvin and 5 atmospheric pressure. So how we are going to do this? So partial pressure of N2 is equals to into the mole fraction of N2 into P total. So if you apply the Henry's law constant. So so that is the partial pressure of N2 is equals to mole fraction of N2 into the total pressure. Okay. So what is the mole fraction? Mole fraction of N2 is given as 0.8 into what is the total pressure? Total pressure is 5 atmospheric pressure. Okay. So find out the partial pressure of N2, 0.8 into 5. 0.8 into 5 is 4. Okay, 4 atmospheric pressure is the pressure of the N2. Okay, it is the pressure of N2. Okay, 4. Yes, Kajal Shri Varuni. Okay, fine. Next step. Next step is what now? Now we have to find out the Henry's constant is given, right? Henry's constant for solubility of N2 is water is this. So by using this, we can find out the this what number of moles of N2, only number of moles of N2. So they have given the number of moles of N2 in from air. Okay, so we have to calculate that. So the pressure of N2 is equals to Henry's constant into mole fraction of N2. Okay, that is your Henry's law. According to Henry's law, then atmospheric pressure, then Henry's constant is 1 into 10 raised to 5 atmospheric pressure, okay, into mole fraction of N2. So what we are going to do, so mole fraction of N2 is equals to, okay, so 4, this is, it will go and divide. So it becomes 4 into 10 raised to minus 5. Fine. So now let us find the number of moles. So total number of moles of N2 is equals to what? It will be number of moles of N2 divided by number of moles of this what? Water plus this, right? We know the formula. That is, if you want to find the mole fraction of A is equals to number of moles of A upon number of moles of A plus B. So similarly, okay, so our this is what? Water and N2, right? So our air and your nitrogen N2 and your water. So what is the number of moles of this? So we have found out the this is 4 into 10 raised to minus 5, that is mole fraction of N2. Okay, next is what? We have to find out the number of moles of N2 from air, right? So let us keep this like this only, N2 divided by what is the total number of this? So number of moles of water, okay, here it is given 10. Okay, 10 plus number of moles of N2. Find out now. So 1 by 4 into 10 raised to minus 5 is equals to plus 10 by 2. So N2 is, so if I transfer up, it will be 4 into 10 raised to minus 4 mole. Okay, so simple calculation. So we have just what we have done. So we have multiplied. So this is, yes, option number A. Option number A. Okay. So just a simple mathematics. Okay. So we have just rearranged it. Okay. So N2. So 1. So this goes this side. We take it at the numerator. So like this. Okay. Simple mathematics. And we'll get the number of moles of this what? N2. Okay. So that is 4 into 10 raised to minus 4. Fine. So this is with respect to Henry's law. Okay, this is with respect to Henry's law. So let us go for the next one. Choose the correct statement. A, KH value is same for a gas in any solution. B, higher the KH value, more the solubility of gas. C, KH value increases on increasing the temperature of solution. D, easily liquefiable gases usually have lesser KH. Yes, we know according to Henry's law, what is our Henry's law? That is P is equals to KH into mole fraction, right? So the total pressure by mole fraction is nothing but your Henry's constant. So when we are talking about the solubility, when we are talking about the solubility of gas, so solubility of gas in liquid is what? It is inversely proportional to the value of KH. So your mole fraction we consider, okay, so the solubility of gas is what? It is inversely proportional to the value of KH. Okay, that is your Henry's constant. So if you increase the temperature of, if you increase the temperature, okay, if with respect to temperature, if the Kf value increases, solubility, what will happen? It will decrease. If you increase the temperature, if the Kh value increases, what will happen to solubility of gas? It will decrease. Why? What is the reason? Because it is inversely proportional. Okay. Kh is inversely proportional to solubility. That is your solubility of gas. Okay. So, your so KH value, what will happen? It increases on increasing the temperature of the solution. So this is correct. Then when you talk about easily liquefiable gases also, okay. When you talk about easily liquefiable gases and they are having lesser value. So this option is also correct. So both these options are correct here. Okay, so when we are talking about liquefiable gases, so they are more soluble. So if they are more soluble, if the solubility is high, what will happen to the KH value? KH value will be less, right? Because they are inversely proportional. So again, yes, option number C and D, both are correct answer. Okay, both correct. Because when we talk about solubility, if more the soluble, what will happen to the KH value? KH value will be lesser. Okay, if higher the value, lower will be the KH value. Lower the value, higher will be the KH value, like that. Okay, so it is inversely proportional. Fine. Let us go for the next one. The KH value of argon, carbon dioxide, formaldehyde, and methane are respectively 40.3, 1.67, 1.83 into 10 raised to minus 5, and 0.413 at 298 Kelvin. The increasing order of solubility of gas in liquid is. So this was a question asked in 2021. So according to Henry's law, okay, so we are going to apply KH into solubility. So we know that KH is inversely proportional to solubility, right? So more the KH, okay, we have just seen now, more the KH value, lesser is the solubility. So what will be the order? What will be the order of solubility of a gas then? Which will come? So KH values are given. So which is the, so what they have asked, the increasing order of solubility. Increasing order means what? From lowest to highest. Okay. So which is the lowest here? So first, okay, from lowest to highest, that is the increasing order of solubility. So the KH value, if the solubility, so the KH value of this is given, the increasing order of solubility of gas is. So the solubility, so 40.43 first will come. Okay, because if solubility is KH value, so more is the KH, lesser is the solubility. And they have asked the increasing order of solubility, increasing. Okay, so it should increase more. Okay, so you have to, so 40.43, then is your 1.67, then is your 0.413, then is 1.83 into 10 raised to minus 5. So this is 1, 2, 4, and 3. So option number 1. Okay, option number A. So more is the KH value, lesser is the solubility. So order of the, this is, yes, Janvi Srivaruni has answered correct. It is option number A. Okay, Lubna has also answered. Good. Okay, I hope you are getting it. Okay, so let us go for the next question. The vapor pressure of pure liquid A and B are 450 and 700 mm of Hg at 350 Kelvin respectively. If the total vapor pressure of the mixture is 600 mm of Hg, the composition of the mixture in the solution is. We know that total pressure is equals to, okay, that is the partial pressure of pure component A into its mole fraction plus partial pressure of pure component B into its mole fraction of B. So by using this formula, okay, we can find out. So we also know that. So what we have here, the vapor pressures, okay, vapor pressure of pure liquids A and B both are given. We need to find out what, and total pressure also is given of the this. We have to find out the composition of mixture. Okay, that is, we have to find your mole fraction A and B. So it can be, so we know that mole fraction of A plus B is equals to 1. So X B is equals to 1 minus XA. So if you substitute this, okay, 1 minus XA. Fine. So let us put the values. Total pressure is 600. Then pure component A is 450 into A plus pure component B is 700 into 1 minus psi A. Yes. Next step. By this, first find out the psi A. What psi A value you are getting, Jesse? So 600 is equals to 450 into psi A plus plus 1, sorry, plus 700, 1 minus A. So by this, okay, so 600, two, three, minus. So just see after solving this, okay, so I'll write directly the value here. So I'm getting psi A as 0.4. Then we know that psi A plus psi B is equals to 1. So if we put the value of 4 plus psi B is equals to 1. So 1 minus 0.4 is psi B is equals to 0.6. So, okay, so we got the composition of the mixture of both. Okay, that is psi of A and psi of B. Yes, so which is the answer? It is option number A. Option number A. Option number A. Okay, let us go for the next one. An aqueous solution contains an aqueous solution of alcohol contains 18 grams of water and 414 grams of ethyl alcohol. The mole fraction of water is. Okay, so simple question based on mole fraction. So first, mole fraction of water. So mole fraction of water. What is mole fraction? Mole fraction of water is what? 18 grams. Okay, so that is 18 gram of water divided by the given weight. It is 18. So first let us find the moles. Okay, that is first we are going to find the moles of water. Moles of water is calculated as given weight upon molecular weight. So given weight is how much? 18 grams, and molecular weight is also 18 gram per mole. So it is 1 mole. Okay, that is what? 1 mole. Now let us find the moles of, we know, okay, we need to find what? We need to find the mole fraction of water. For that, we know we need what? Mole fraction, number of moles of water upon number of moles of water plus number of moles of ethyl alcohol, right? So for that, we are calculating the number of moles now. So number of moles of ethyl alcohol. Let us calculate ethyl alcohol. So what is the given weight? Given weight upon molecular weight. What is given weight, students? 414. Okay. And ethyl alcohol is CH3CH2OH. Calculate. Okay. Carbon, 2 carbons, 12 plus 12. Then hydrogens, how many? 3, 4, 5, 6. 6 hydrogens, and oxygen is 1. So 24 plus 6 plus 16. 46. So it is 46 gram per mole. Gram cancels. Okay, gram cancels. What it will be? 414 by 46 is how much? 414 by 46 is 9. 9 mole. Okay, 9 mole. Now find out, put the value. This is the formula. Okay, mole fraction of water. Number of moles of water is how much? 1 mole. Number of moles of water is 1 plus ethyl alcohol is 9. So it is 1 by 10. 1 by 10 is what? 0.1. So the mole fraction of water is 0.1. Okay, so option number C. Are you getting? Yes. Very good. So Lubna, Sri Varuni, Janvi. Yes, very good. Okay, I hope this is clear. So whenever mole fraction is asked, okay, so you need to know first the number of moles. Okay, so number of moles of water, then number of moles of ethyl alcohol, then we have substituted in the mole fraction formula and we have got the mole fraction of water. That is 0.1. Okay, is it clear? Okay, let us go for the next one. Which of the following colligative properties can provide molar mass of proteins, polymers, and colloids with greater precision? A. Depression in freezing point. B. Osmotic pressure. C. Relative lowering of vapor pressure. And D. Elevation in boiling point. Provide molar mass of proteins. Okay, to calculate the molar mass of protein. So, which is the best, or you can say, which is the colligative property they have asked. So, the answer for this is, okay, Sri Varuni has answered it as B. Yes. Okay. And Janvi has also answered it as B. So for calculation, for measuring okay, osmotic pressure, correct. The measurement of osmotic pressure method, okay, it is preferred for the determination of what molar masses of protein, polymers, and colloids, okay, because it involves what? It involves molarity. Okay, it involves molarity and not molality. So osmotic pressure we are considering. So when we are calculating the molar masses of protein, polymers, and colloids. Okay, so option number B, sorry. Okay, let us go for the next one. Solubility of gas in liquid increases with, yes, again Henry's law. Again Henry's law. What is according to Henry's law? According to Henry's law, solubility of a gas is inversely proportional to the, yes, solubility of a gas is inversely proportional to the Henry's constant, right? And solubility of the gas is, solubility of a gas, this is a pressure, that is a partial pressure of gas. is equal to the Henry's constant into the mole fraction of gas. Okay. So solubility of gas is directly proportional to the partial pressure. Okay. This is directly proportional, the partial pressure, and your uh, is inversely proportional to your Henry's constant. So on increasing the temperature, solubility of gas decreases on increasing temperature. Okay. So as you increase the temperature, what will happen to solubility of a gas? The solubility of a gas, okay. This we are writing here solubility, sorry. So on increasing the temperature, so as the temperature increases, what will happen to solubility of the gas? The solubility of the gas decreases, okay, as because of the kinetic energy also increases. So it decreases, sorry, not increases, it decreases. So which is the answer? It is A. So increases of P, okay, and decrease of temperature. So solubility of a gas in liquid, okay, what happens? It increases of pressure. So as solubility increases, pressure also increases. And what will happen as you increase temperature, solubility of the gas also increases. Okay, with decrease in temperature. Fine. So this is the answer. So option number A. So elevation and boiling point, this we have done. Okay. So again, if you want, you can note it down. You can solve. Okay. So if you want, you can note it down. So it increases with decrease in temperature. Yes, very good. So Janvi and Sri Varuni have answered it. Very good. So please, you can note it down, this particular question. Okay, you can solve this. So we have solved such questions. You have to find the molar elevation constant of the liquid. Okay, so just copy it down. You can solve the similar question. Let us go for the last question. If 3 grams of glucose, whose molar mass is 180 gram, is dissolved in 60 grams of water at 100 and that is 15 degrees Celsius, the osmotic pressure of the solution is. So what is osmotic pressure given as? Osmotic pressure, we know that osmotic pressure is given as what? It is given as pi, which is equals to CRT. Okay. So here, what is concentration? We know that concentration is nothing but number of moles. Okay, that is a moles of solute upon the volume of solution in liter. Okay, so what is the number of moles again? Number of moles is given weight upon molecular weight. Okay, and so what is the given weight is? Given weight is your 3 grams. What is the molecular weight of the solute is? Solute is what? Our glucose is the solute. So 180. Then volume of solution. Volume of solution in liter. So what is volume of solution is? 60 grams. Okay, 60 divided by 1000. Okay, 10 raised to minus 3 is nothing but 1000. Now, so find out the concentration. So 3 by 180 into 1000 by 60. 30 by 18 into 6. So what is the answer? Just see, I got concentration as 0.277 mole per gram. Sorry, mole per kg. Okay. So I've got the concentration. Now, what they have asked, the osmotic pressure. What is the osmotic pressure? Now, let us put the value. So we have to find the value of pi here. We have got concentration. Now, let us find the osmotic pressure. Concentration is 0.277. What is R value? R value is 0.0821. Okay, into the temperature. What is the 15 degree? 15 degree means 273 plus 15. 73 plus 15. 8, 7, 8. and 2. So 288. Okay. So this is in Kelvin. This is in liter per atom per mole. Okay, per kg. So find out. And this is mole per liter. So the value comes to be, after solving this, it comes to be 6.55 atmospheric pressure. So the pi osmotic pressure is 6.55. Everybody got? Yes. Okay. Fine. Is it clear? So are the questions clear? Okay. I got 6.5. No problem. 6.5 is the correct answer. Okay. Fine. So by this, we have completed the MCQs on solution chapter. Okay. So next class, we are going to start with the next chapter, that is haloalkanes and haloarenes. So please go through the synopsis of haloalkanes and haloarenes. Okay. So whatever we have completed in the ACE program, so there already I have discussed the theory part. So here we are only going to discuss the MCQs. Okay. So yes. So next week we are going to see the chapter haloalkanes and haloarenes. So before coming to the next class, please go through the chapter. Fine. So by this, I'm going to end the session here. Okay. So we'll meet in the next week. Thank you.